Sublimation or deposition, the choice is yours. At least in this class, the choice is yours. What that is this. It occurs when water goes from a gas or vapor, synonyms of course, into a solid, bypassing the liquid state. In order for this to happen, the dew point temperature has to be 32 degrees or lower. For our purposes, there are two forms of sublimation. Here's what they are: frost and snow. Let's start with frost. Frost forms almost exactly the same way as dew. The primary difference between the formation of dew and frost is temperature. The dew point temperature for frost needs to be 32 degrees or lower. Last year, I was riding my bike through Yosemite at Thanksgiving, and there's a bridge that goes over the top of the Merced River, and as I was riding along, I saw the entire bridge was covered in frost. What happened was this. At night, that wooden pylon that you see there dropped below 32 degrees, and the air that was in contact with it reached the dew point temperature, which was below 32 degrees. The result of that was water had to be squeezed out. It was 100% relative humidity. The air was saturated. But below 32 degrees, instead of the water being squeezed out in little tiny droplets of water like little BBs that form all over on your car, what's going to happen is it's going to come out as an ice crystal. And there it is. That's frost. It's actually very simple, just like dew. Just instead of the dew point temperature being above freezing, it's below freezing. But the same process happens. The object has dropped below the dew point temperature, and in this case, the dew point temperature was below freezing. If you take your hand and you rub it across, that frost actually makes like a little snowball. Beautiful, isn't it? It's almost like hair growing on it. Snow forms in a similar way to rain, but it's a bit more complicated. So during that same trip I just mentioned, when we arrived in Yosemite, there was no snow on the ground, and then over the next about day and a half, 3 feet of snow fell. It's beautiful. This is how it forms. Take a look at this diagram. First, I want you to notice this. Frozen air begins to produce ice crystals while supercooled liquid water remains in the air. What that means is, if you look at that top rectangular diagram there are cloud droplets. Crazy as it may seem, when the cloud first started to form, the temperature was above 32 degrees, air temperature, dew point temperature, the same number, and water began to be squeezed out in the liquid form, so little droplets of water went around all of the condensation nuclei. Okay? That was the cloud. But then the temperature continued to drop. And once the temperature went below 32 degrees Fahrenheit, instead of liquid water being squeezed out, ice crystals began to be squeezed out onto what would technically be called sublimation nuclei. It's the same thing. It's just that the temperature's lower. So now the cloud was made up of two things. It was made up of ice crystals and little droplets of water, both things. Why didn't the water turn to a solid? It's a weird thing. It's called supercooled water or supercooled liquid, where the water can maintain the liquid state below freezing. In fact, very, very far below freezing. Liquid water can still remain in the liquid state under certain circumstances. That's what's going on. At the same time, watch this. When we go to the next panel down below, ice crystals grow as more water is squeezed out of the air. Meanwhile, the air becomes drier because colder air holds less water. So this is kind of complicated. But what's going on is this. Remember when I gave you the analogy of the glasses? A 16-ounce glass can hold more water than a 12-ounce glass, okay? And with regard to specific humidity, of course, a 16-ounce glass would be holding 16 ounces of water if it was full, and a 12-ounce glass would be holding 12 ounces of water, right? Remember that the 16-ounce glass represents warmer air, the 12-ounce glass represents colder air. As the air drops in temperature, it can hold less water. The primary reason is what happens is the air molecules become denser. In other words, they get closer and closer together, and there just becomes a point where you can't really fit as much water in because there's no space in between the rest of the atmospheric molecules because the air gets dense when it's cold. At the same time, even if the relative humidity is 100%, cold air holds less water, which means it is drier from a specific humidity standpoint. Therefore, in that second panel, as the air temperature is dropping, What's also happening is the air, even though it's 100% relative humidity, is drying out. That causes those cloud droplets that are liquid water to evaporate. That was my finger snapping. And then almost immediately, they resublimate onto the already formed ice crystal. So that dropping temperature causes the air to get so dry that the liquid dries out and turns into a vapor, and then it resublimates onto the ice crystal. As that continues to happen, notice as you're going down, there's fewer and fewer of those little liquid cloud droplets. As that happens, the ice crystal grows larger and larger and larger. Eventually, it turns into a full-blown snowflake, and then it begins to fall to the ground because it can no longer be held up. It's not buoyant anymore. It's gained too much mass and too much weight. This is actually called the Bergrum process after, I think it was a Norwegian meteorologist who discovered it and figured it out. You know, if you discover something, it gets named after you. So again, take a look at that picture. Now you know this is the way that snow is forming. Originally, the cloud had liquid water in it. The temperature dropped. Ice crystals began to form. The liquid drops began to dry out because the air was dry, because it was colder, not because it wasn't 100% relative humidity. It was 100% relative humidity, but the air just holds less water, which makes it drier. And then as a result of that, that dried out, evaporated water then resublimates onto the ice crystals. They get bigger, and eventually they fall.